Hello and welcome to WVU. My name is Paul Chantler and I'm an Associate Professor here in the School of Medicine. Research in my cardio-cerebrovascular laboratory is focused on how certain disease states such as aging and obesity or exposure to chronic conditions such as stress or e-cigarette exposure mediates vascular biology. My lab operates both human and animal models, and that this approach allows us to further explore the underlying reasons for the vascular consequences of this disease progression. Recently, in animal models, we have focused on the brain and understood how chronic stress induces vascular damage and contributes to cognitive impairment. This project is funded by NIH. Another area of research is exploring how e-cigarette exposure affects vascular biology, and this is a collaborative project with Dr. Mark Alford. Again, here we use animal models, both rats and mouse, and this is funded by NIH and AHA. Importantly, because we're members of the Center for Inhalation Toxicology, Center for Basic and Translational Stroke Research, and my strong collaborations outside the lab with PhysPharm, Neuroscience and Immunology ensures that the lab is positioned in a fertile and collaborative environment for successful completion of our research aims, the establishment of new techniques and new research goals. Indeed, part of what you will learn when joining the lab is a whole host of both functional as well as molecular techniques. From a functional perspective, we use ex vivo vascular biology techniques such as myograph, but from an in vivo approach, we are establishing an intravital 2-photon microscopy to get high-resolution images of the cerebral vasculature and the consequences or changes associated with disease progression in the brain. In addition, we use flow cytometry, Western blots, ELISAs, etc. to explore the reasons behind the progression of the pathology. In addition, we create our own mouse models to specifically target research hypotheses and address those aims directly. Thus, when coming into the lab, you will get exposure to all of that. I have 2 PhD students and 2 master students with a whole host of undergrads to support the research. And part of what I like to do, and critically I feel is important, is that the PhD students and graduate students work together on each other's project. This increases the techniques that you will learn, allows you to work in a collaborative environment, but importantly, it increases the publications, both manuscripts and abstracts, as well as exposure to various scientific conferences, which is key to your progression. Rotating through the lab will look like the following. You will shadow one of the graduate students, understand their role, what they do day in to day out, as it is not a 9-to-5 lab. And that way you'll get a good understanding of what the Chantler lab is about. I have graduated 4 PhD students as direct mentor, 3 to 4 as a co-mentor, and a whole host of master students have progressed through my lab. Indeed, students who graduate from my lab typically have 3 to 4 publications, depending on how successful and how hardworking they are as they go through the project. So, thank you, and I look forward to seeing you. Goodbye.